How's it going, guys? In this video, I'm going to show you guys how to do the simple 3D simulations that you can do in Solidworks on your 3D model that you've created from the previous video. So here we have our hollowed out cylinder, which is our simplified bone, and I've given it the MA bone or middle-aged bone material properties that I created in the last video. So we're going to go to SolidWorks add-ins, it's a tab on the top, and we're going to click on the SolidWorks simulation button. And I've already clicked it because it takes some time to load, and once it loads, it'll create a simulation tab. Once you click on that tab, we're going to go to New Study, and we're going to make sure this is at static, and then we're going to press OK. So now we have all the components of our static simulation on the left side. And when you're doing a simulation like this, and in this case it's going to be compression, we're going to have to fix a part of this bone. So let's assume that this is a tibia, and the person who has this tibia is taking a step. So when they take this step, they're going to be planting their foot and then essentially fixing the distal side of the tibia. So we can assume that the distal side is going to be the bottom of our 3D model. So we're going to right click on fixtures on the left side and click on fix geometry. You'll see these green arrows come up, and these are just the fixtures that it is preparing to place. We're just going to put it right on the face, the bottom face of our hollowed out cylinder. And then we can press OK. So now the bottom face of our bone is fixed, and we just have to now add a compressive force on the top of our model. So now we're going to go to external loads and right click that and click on force. You'll see these purple arrows come up, and then we're going to just put it right on the face that we did not fix. We can give it some arbitrary force, like 250 or so newtons, and then we're going to click on the OK check mark. So now if we look at it from the side, you have the fixtures on the bottom and then the straight forces on the top, and now we're ready to run our study. So there's a run this study button on the top. Click that, and it shouldn't take too long. And now we have our results. It's pretty quick. So we have, on the left side, you'll see stress, displacement, and strain. So these are the three main results that you'll get. And as you can see, the model is now multicolored, and that just coordinates or is associated with a different force or different strain in this case. And you'll see that these colors are just in the legend as well. And in this case, for the stress, it is in newtons per meter squared. And you can see that there's some striation going on here, and a lot more stress at the fixture. If you go to displacement, you'll see the whole range of colors going on. The bottom where it's fixed has a lot less displacement than where it's not and where the force is. And we can go to strain, and you'll see there's a similar kind of coloring pattern as the stress. So with these three, you can compare the two different types of bones that you're going to be creating for your project, which is going to be young and old. And while the banding, if there is any, might be the same for both of your young and old models, the different colors may be more apparent. So you gotta be careful about what colors you see and what force or strain they're associated to. So I think that's it for this video. This should help you work on your first assignment, which will be working with compression and creating your model. And in the next video, we'll tackle some of the other simulations, such as torque and bending, and we'll work from there. All right, see you guys.